If you followed along with this course so far, we've walked through basic descriptives and summary statistics and how that starts to give us some information on our data that we have. What we're going to do in this video is we're now going to move towards the distribution of the data and graphing the data. In the first section, we'll cover the theory behind histograms. And in the second session, we're going to then show you a couple of examples of histograms that you can do in order to start to understand and get information about your data. We'll continue to use the same data that we have in the previous videos, which is the report mark data. But if you haven't got that data on your computer, you can download it from the link below. And we strongly encourage you to follow along as we do the practical steps of this exercise. The reason that we like to graphically illustrate our data is that even though the descriptive statistics that we've shown you so far do give us a nice summary and an indication of what is going on with our data, they could still hide some important information because you're essentially summarizing a whole lot of data in just 3 or 5 statistics. And then also, even though it's a lot simpler to look at the summary statistics, that can still be too much information to interpret at just a glance. So graphs make it a lot easier to just look at something and immediately have an idea of what's going on in our data. For this session, we're going to use 30 test scores that are listed over here, just as a simple example for how we can set up a histogram and basically explain the theory behind a histogram. And then we'll give you some Excel examples that we'll work through together in order to set up a histogram using pivot tables. To create a frequency histogram, what we do is first we group our observations together into what we call bins. And then we plot on our graph how many observations fall within each bin. For our test score example, because it's test scores, it maybe makes sense to group it in bins of 10. So marks from 0 to 9, 10 to 19, 20 to 29, all the way up to 90 to 100. We can focus here on the 70 to 79 bin. And you can look through this data and check, I've highlighted in red, there are 10 observations that fall within the 70 to 79 bin. And we can then plot this on a graph. So where there's the 70 to 79 category, we plot that there are 10 observations. If we do that then for every single bin or every single group of numbers, we'll get this graph that you see here on the right, and you can test for yourself. You can go and count and see, are there 7 observations that lie between 90 to 100? And a question that one often gets asked is, how do you decide what size your bins should be? And this very much depends on your data and what makes sense. So if we go back in the previous theory session, we spoke about if it was the annual school spending, then you're not going to want to do that in bins of 10 Rand because you're going to have so many bins because the spending probably varies by quite a large amount. But if we're dealing with marks, then you can make a bin size of 10 or 20 or maybe 5 makes more sense. So the size of the bin can be a matter of preference, but you do want your bins to generally have the same size. So you don't want to have one bin of 20 and one bin of 10. Because we want to have all of the bins be equal representations so that we can see if there is one bar that is a lot higher than the others, that means the same information. It means there's a lot more of our observations in that group than in the other groups. So what we've done there is a frequency histogram. What's also useful is what we call a relative frequency histogram. This is particularly useful when we are comparing different sized distributions. Because for a relative frequency histogram, instead of showing the number of observations that fall into each category or each bin, we rather show the percentage of our data that falls within that. So if we now focus on a different bin, but the same data, so 5 of the 30 observations are in the 80s. You can see them highlighted here in red. They're 30 observations. So in total, 5 divided by 30, or 16.67%, of our observations lie in the 80 to 89 bin. And this is what we call then the relative frequency. So we can plot this on the graph, and you can see that number over there is for the 80 bin. You can go back in the video and you can check the size of this graph and the shape of the graph is identical to what we had when it was just a frequency histogram. The only thing that has changed here is what's written on the y-axis. So now instead of writing that there were 10 observations in the 70 to 79 bin, or that there were 5 observations in our 80 to 89 bin, we now write the relative frequency. So it's now shown as a percentage. By necessity, this means that if you add up all of the sums over here, that's going to sum to 100%. So now if you are comparing, like in our previous video, maths versus maths lit, where there aren't the same number of learners with you choosing those subjects, it's quite useful to do a relevant frequency histogram because the size of the bars doesn't depend on the size of your data. What Chris is going to talk you through now and show you, and I'll talk through some of the interpretation, is we're going to show you how to do frequency and relative frequency histograms in Excel, and also show an example where we compare the distributions of marks in two different subjects so we can see visually the differences between the two and see what information we can gain from that.
So to show you how to do a frequency distribution table, I'm going to use a pivot table to do that. And to do that, you need to be in the data. And again, I'm going to use the same data, which is the anonymized report marks grade 9 maths as an example. So again, Control A to select all the data, insert, pivot table, and OK. And to build the pivot table, the bins that Rebecca was referring to is I use the marks variable and put it under rows. So this shows the marks that the learners obtained. Before I want to count what was the number of learners within each these mark groupings, I want to first filter it for maths grade 9. So I use the subject as a filter and then select only the maths grade 9 learners. And now I want to count how many learners within maths obtained all these values. So, and I use the unique ID of the learner to do the counting for me. What this means is there was 3 learners that obtained 11%. There was 93 learners that obtained 22%. But you can see it is quite a long list. And the best way to do this is to group this like Rebecca showed with the bins, that you change this into bins where you have 0 to 9 or 0 to 20 or 0 to 5, whatever the grouping you want. So in Excel, there's a nice feature. And to do that, I need to be inside this column. And then right click, and there's an option that says group. And you can decide what grouping you want to use, what bin size you want to use. I'm going to use for now size 10. And because we work with percentages, I always, when Excel uses the maximum value, I use the value, because this was out of percentage, I use 100 as the total. So, okay. And now you can see these are the bins or the groupings that learners obtain for math grade 9. 175 learners obtained between 10 and 19%. 129 learners obtained between 60 and 69%. So this is called a frequency distribution table. So how frequent did learners obtain between 0 and 9? And in this case, it was 2. So that's why I call this count of learners the frequency. That is the frequency, because this is a frequency distribution table. And then this grouping, I'm simply going to call it an interval. What are the intervals that we use within this frequency distribution table? So this is the table. But I can add a graph to this. I can add a histogram to the frequency distribution table. And to do that, I need to be inside the table. Go to Insert. And again, I get this cluster of graphs. And to draw a histogram, I go to this column graph section. And the first one, that's the one that I want to use for my histogram. Open up that, and then I clean it up a bit, do the formatting, get rid of the legend. I want to get rid of my heading or my title. Again, these buttons within the graph, I'm going to right-click, hide all field buttons on the chart. That's the first step that I want to do. So this is almost there. Now I want to get rid of all these spaces within the histogram. And to do that, I need to click on any of these bars, right-click, format the data series, and then I'm going to change the gap width. In this case, I'm going to change the gap width to 3 so that I can distinguish between the bars. And that's a good example of a histogram. I can also add these values to see what is the number of learners within the graph that obtained within that grouping. So I simply click any of these bars, I right click and I say add the labels. And now you can see that 69 of the learners obtained between 70 and 79%. So this gives you a good indication of the performance of learners for math grade 9 in this data. But I can also, it's sometimes useful, instead of having the frequency where we have numbers, change that to relative frequency. What does that mean? It means that that 2 is relative to the total. 175 is relative. So if I change this to percentages, it would be the end would be 100% of learners. So what is that 2 relative to the total? And to do that, there's another feature in Excel that does that for you. So you need to be in this column to do that. Just take note that for now, the y-axis is numbers. That shows numbers. So I'm going to change this now to percentages. But before I do that, I want to change the table here to percentages. To do that, to change this frequency distribution table to a relative frequency, be in this column, right click, and then say again, show values as, and in this case, it is percentage of column total. Why? Because that 2 is relative to the column total. 279 relative to the column total. I right click, show values as a percentage of the column total. And now you can see, and I want to change that to 1 decimal. And now you can see it changes to percentages here, and also in the graph, it changes to percentages because it is now relative frequencies. I can change that to relative frequency. And that is what this graph and the frequency distribution table display. Now that we have this, I want to use the same graph, but I also then want to add something new. It's to compare the maths grade 9 with the English first additional language grade 9. And to do that, I first want to make sure that I know which graph this is. So I'm going to add a title to this. And to do that, I click on the graph. There's a plus sign, and I simply click on the plus sign and then say add the chart title. Now you can see there is a space for the chart title, and this one would be the maths for grade 9. Then I want to add another relative frequency distribution table, but I want to do that for English first additional language, also grade 9. So that I have 2 graphs next to each other, which we then can compare the performance of learners between those 2 subjects. So let me first add another pivot table on this side. So to do that, I want to close this area so that I have a little bit more space. I simply close that. So what I want to do is to add another pivot table. I simply copy this pivot table, right click and copy, and then I'm going to paste it in this area, and I right click and simply say paste. Now I have exactly the same table. This is for maths again and maths grade 9 again, but now that I have a filter, I can change this maths in this pivot table to English first additional. I simply go to English first additional grade 9 and say OK. So this frequency distribution table is now for English first additional language. And I can now add also a graph to this like I did with the math. So I'll be inside this pivot table, go to insert, and then use this column graph as an example, and then clean this graph again like I did with the maths. Get rid of all the buttons. Take that legend out, change this heading to English first additional language, and then change this again to a histogram, not a bar chart. And to do that, I simply get rid of all the spaces by changing the gap width to 3. And there we have it. And I'm going to put these next to each other so that we can compare that. Compare that and make this a little bit smaller so that I can fit that in there. And this one the same. I'm going to make that exactly the same size like that. And now we can compare the two graphs. English first additional language versus maths grade 9.
So here you can quite easily see the advantage of using graphs. Summary statistics, we could have got an idea of the differences in the marks between grade 9 maths and grade 9 EFL, but the graphs are quite a quick way to get that same information very simply. So here we can see that in maths, the highest bar over here, and I'll just remove the labels, you can see the highest bar over here is in the 30 to 39 category. So the highest proportion of maths learners are falling within that 30 to 39 category, whereas for EFL, we can see that it's higher over there, so in the 40 to 49 category. So that's one bit of information we can get from this graph. We can also see that in EFL, there are very few very low achievers. So it looks like there are almost no learners who are getting less than 20% for EFL. In maths, that's not the case, but there are no learners getting between or under 10%. We can also, just by looking at the shape of the graph, you can see which side essentially is bigger or which one has the higher bars. And do you see EFL looks a lot higher, or there are more bars on the right? Maths is a lot more on the left. So this is showing us that EFL achievement, or English First Additional Language marks, are a lot higher than the maths marks, because a lot more of them are in the 50 to 59 or 60 to 69, 70 to 79, compared to maths, where most of the marks are between 10 to 40%. The next video that we're going to be doing is we will be looking at more ways to graph out data, specifically using scatter plots, where we'll do the theory first and then we'll do some more Excel demonstrations.